Thank you for joining this physics lesson. We are going to continue with uniform circular motion. We have already introduced circular motion, and in this session I wanted us to compare what we call centripetal force and centripetal acceleration. Centripetal force and centripetal acceleration, small letter A. Earlier on, we had mentioned that a body in circular path is accelerating, and due to that there must be a force behind that acceleration, because according to Newton's laws of motion, even linear motion, we know that there is a force which leads to every acceleration. So acceleration of a body in a circular path is called centripetal acceleration, and the force behind centripetal acceleration is called the centripetal force, and this is the force which sustains a body in the circular path. Therefore, centripetal force depends on three main factors. Centripetal force depends on three main factors. And the first one is mass of the body which is going through the circular path, small letter m. Another factor is the linear velocity, so the linear velocity, small letter v. And finally we have radius of the path, radius of the circular path, small letter r. These three affect centripetal force such that centripetal force is directly proportional to the mass of the body. So a bigger mass requires a bigger centripetal force to be sustained on the circular path. Similarly, if a body is going at a very high linear velocity, it requires a large centripetal force to be sustained on the circular path, such that the centripetal force is directly proportional to the square of that linear velocity. Then a radius which is very small requires a very large centripetal force, or rather centripetal force is inversely proportional to the radius of the path, and this will make radius to be on the denominator. Therefore, we can do away with the symbol of proportionality by introducing a constant of proportionality, such that F equals to a constant m v squared out of r. And if we let k to be 1, then we will talk of centripetal force being given by m v squared out of r. After this, we can recall what we call Newton's second law of motion, which says that the force is usually given by mass times acceleration. So in this case, because we are dealing with centripetal force and centripetal acceleration, then we can say force centripetal is given by mass times acceleration, which is centripetal. And according to this equation, and the other one here which gives us centripetal force, since we have mass and another factor here, we have another term there, v squared out of r, then we can say that term will be equal to the centripetal acceleration, because we have centripetal force being given by mass times v squared out of r, and on the other side we are saying that every force is given by mass times the acceleration. So this can make us conclude that then acceleration, which is centripetal, is given by v squared out of r. And since according to the relationship between centripetal force and angular velocity, remember we had said that v is given by omega r, then we can say again centripetal acceleration is given to v, instead of v, omega r squared, then divided by r. So instead of saying acceleration equals to v squared over r, we can just have these ones squared because they give us v out of r. So acceleration is equal to omega squared multiplied by r. Since 1r, when it becomes squared, 1r will cancel in the 1 in the denominator. So if centripetal force equals to mass times acceleration, and the acceleration is also given by this, alternatively, centripetal force can still be given by mass omega squared multiplied by radius. Omega squared multiplied by radius. So this is the relationship between omega, the mass, the radius, the linear velocity, and the centripetal force of a body which is in a circular path. Thank you for following. Subscribe to Shifting Grades and share the link with your friends. In case of any queries, kindly contact me through 0704 153 366. Thank you.